All right, welcome to my lecture on estimation of the binomial distribution. So let's get started. Okay, and there's going to be important fact that we're going to use here. So first we're going to do two methods. So part A is going to be the method of moments, and part B is going to be the maximum likelihood estimator. And I'll often abbreviate this just by MLE. Okay, so let's get started. Part A, so the first step is to collect data. And let's call this data x1 through x2 through x sub m. Okay, so there are m observations. And let me just remark, each observation consists of observing a binomial experiment in which an experiment is repeated n times, and the number of successes out of n is recorded as data point x sub I. Okay. So now let's move on to part two. Part two of this says that the expected value of x is equal to the average. So this part, this comes from the distribution. And the distribution of a binomial has mean n times p. That's the expected value. Okay. And x bar, that's the average of the observations, is going to be x1 plus x2 plus x sub m divided by m. So our estimate for the unknown probability of success, P, is going to be x bar divided by n. Now we'll label that as our estimate by putting our hat. That's our estimate Okay. Now, let's move on to part B, which is the MLE. So our first step is the same. Let's pretend that we have data x1 through x sub m, but our second step is to form the likelihood function. And that's going to be f of x1 comma p times f of x sub m comma p. And these are just the density functions. We know the equation of a density function for a binomial. This is going to be n choose x sub I times p to the xi times q to the n minus x, x sub 1, okay, times the likelihood function of x sub 2, n choose x sub 2, times p to the x sub 2, times q to the n minus x sub 2. And we're going to keep going like this. We're going to keep going like that n times to the n minus x sub m. Now we're going to combine terms. And the first term that we're going to have is going to be n, choose x1. And we're going to have a bunch of these combination terms. Okay. And I'm just going to write it as the first and the last. Then I'm going to write down the value of the p's. So from the p's, when we add those all together, we're going to have p to the x1 plus x2 plus x sub m. Then I'll do the q terms. Q, so we'll have m of those, and we'll have n minus x sub 1 plus n minus x sub 2 plus so on plus n minus x sub m. And then we'll just simplify these terms. Okay, so we'll have n choose x sub 1 times n choose x sub m. Those are multiply symbols. Times p to the summation of x sub I times q to the n, and there are mn, so it's n times m minus the summation of x sub I. Now I'm going to simplify this, I'm going to take the log of the likelihood function. And I'm going to call that little l of the unknown parameter p. And this is going to be a log, applying properties of log, it'll be n choose x1 times n choose x sub m. Okay. Then the multiplication becomes addition, so plus the log of p to the summation of x sub I plus log of q to the n times m minus summation of x sub I. Now, I'll have the log of that first term, and choose x sub 1 times n choose x sub m. Then I'll apply the rule of exponents here, plus the summation of x sub I times the log of p, plus I'll have n times m minus the summation of x sub I times this log of q, which is going to be 1 minus p. Now, our next step is to take the derivative here. And keep in mind, the derivative is with respect to p. Okay? So we're going to get L prime of p is going to be 0 for that first term, plus summation of x sub I over p, plus n times m minus summation of x sub I times the derivative of 1 minus p, which is that times a negative 1. And we're going to set that equal to 0 since we want to maximize p. So our third step is to solve for p. Okay, so we'll clear the denominator. And we're going to get summation of x sub I plus p times n times m minus summation of x sub I times a minus 1 is equal to 0. So we'll have summation of x sub I minus p times the summation of x sub I minus p times n times m plus p times summation of x sub I equals 0. Now I get to cancel that term and that term. And I'm going to have that summation of x sub I is going to be p times n times m. And so I can solve for the unknown parameter p, and we'll get that this summation of x sub I is going to be equal to p, and I'll have to divide by n times m. And that's the same estimator that we got before, because if I look at this piece, that's x bar divided by m, and that's p hat. This is our estimator. Okay, and that is the method of moments and the method of the maximum likelihood estimator.